Hey YouTube, what's up? Dr. T here. You are looking at DeepMind's famous Nature cover of their Hey YouTube, what's up? Dr. T here. You are looking at DeepMind's famous Nature cover of their Atara Games paper, Human Level Control Through Deep Reinforcement Learning. DeepMind may not be a household name in the West, but AlphaGo is at least in the Far East. Founded in 2011 in London, UK by Demis Hassabis and colleagues, it was acquired by Google after the Atara Games publication in 2014. With over 500 employees, many at the PhD level, they offer a hybrid environment in between the academic world of the university and the commercial world of industry. So let's go and take a look at DeepMind as it was 2 years ago.
Not much is known about DeepMind. If you take a look at their website, you'll see that their goal is to solve intelligence and that they're currently hiring. What we do know is that having been founded in 2011, they were then bought by Google in 2014 for a whopping £400 million. Today, they're publishing a major piece of research in Nature, and we're getting the opportunity to look inside their offices.
We're not headed to Silicon Valley, but to the heart of London, where behind a relatively unassuming, unmarked door sit some of the brightest computing minds on the planet. One of the company's co-founders is Demis Hassabis, a chess prodigy, computer games designer and neuroscientist with a passion for artificial intelligence.
So we already have Siri, we have photo recognition, computers are pretty smart, but how will this research take us forward even more?
So I think all those examples you just gave are examples of some smart tools that we currently have, but they're very limited in their domain in terms of what they can actually do. And I think the big challenge for society over the next decade or two is actually dealing with the massive amount of data that is being collected on everything from healthcare to economics to climate and so on, and actually trying to make sense of that data and finding the structure in that data and the insights to allow us to solve whatever it is we're trying to do. And I think we're going to need the type of algorithms we're building here in order to be able to find those insights in that massive, overwhelming amount of data.
And the paper that you're publishing now in Nature, that starts down that path by playing Space Invaders.
Yeah, that's right. So really it's just the very first baby step towards that grander goal. But really the paper and the work in that paper is the first example, I would say, of a full system that can actually learn to master a wide range of diverse tasks.
So take me through what the algorithm does then, step by step.
So the first time the algorithm encounters a game, it sees the data stream for the first time, so it's a little bit like a baby opening their eyes and seeing the world for the first time. So the only information they get is the pixels and the game score, and the goal they've been told is to maximise the score. But apart from that, they have no idea about what kind of game they're playing, what their controls do, what they're even controlling in the game. All it can do at the beginning is trial and error, press the buttons randomly, and see if they do anything. And then over several hours of experience, maybe even many days, it starts figuring out what it's controlling in the world, patterns in the world, building a model, if you like, of how the world is working. This system kind of learns to and adapts and gets better and better incrementally till eventually it becomes almost perfect on some of the games.
And this system that you've created can play not just one of these games like Space Invaders, but a whole different array. Why is that such a challenge?
Well, it's very difficult to build one system that can actually master a wide range of different kind of goals. So really the only way of doing that is to actually have the machines and the algorithms learn for themselves directly from the data.
To find out more about how the algorithm works, Demis took me to meet two of its creators, Vlad and Corey.
Hey. So if we were to hear inside this algorithm, what is it that we would see?
Right, so the core part of the system is a big neural network, which essentially gets frames from the game as input, and then it extracts layers of progressively more abstract features. So maybe at the lowest level it would represent information about which pixels are on, and when you go to the higher levels it will start to represent positions of the ball or maybe of the Space Invaders. And what the system produces as an output is essentially a prediction for how much reward does it expect to get if it presses this key right now and continues playing.
So we've heard a lot about what the system is very good at doing and the certain games that it can play. What does it find more of a challenge?
Right, so one issue with the current system is that it essentially starts playing the games by just randomly pressing the keys. And in a game like Space Invaders, you can press spacebar a few times and you'll hit a few of the enemies and you'll get points. But in other games, it's very difficult to get your first points or first reward. So if the game involves solving a maze, pressing keys randomly will not actually get you any points, and then the system has nothing to learn from.
So is that why it's not quite so good at playing Miss Pac-Man?
So that's one of the issues. There is a maze involved, and it has to explore the entire screen. But it's also a game where longer-term planning is an issue.
And so why does it find long-term planning difficult?
Because in the current system, it takes a short history of what it has played, but it doesn't have a real memory component. So it doesn't have any means to remember what it has done far into the past. So it can't use that to plan far into the future either.
Is this just a problem of sheer computing power? Can we just give it more memory?
It is not that, because even if it has more memory capacity, what is important is to be able to use that memory capacity to actually decide on what to put into that memory and what to read from that memory. And that is a whole new aspect of research that we are working on.
Learning to play a variety of games is impressive, but clearly a long way off what we think of as intelligence. Space Invaders may be an unusual first step, but then DeepMind are an unusual company. I joined Demis for one last chat at their weekly Friday drinks.
So you're publishing this research and the code in Nature. Aren't you giving away your secrets to some extent?
Well, I think we use it as a company, we think it's important to share these advances with the community. And we also think it's very important to have an independent validation of the quality of the work that we're doing.
And of course you are owned by Google. Why Google? I presume it's not just because of the drinks on a Friday.
Well, at Google actually our cultures are very similar, so there's a lot of alignment actually with Google's culture and DeepMind's culture. But actually the main reason we decided to join forces with them was we felt that we could accelerate the progress we're making if we use the complementary things Google have, like compute power and data and so on, and the things that we were good at, like the algorithms and so on. And that's turned out to be really the way it's happened, so it's been really, really good. Well, the thing I get most excited about, if we look sort of 10 years plus out, is using developing the type of technology that we publish now a lot further, and building up those capabilities so eventually we can have, say, scientific advances being assisted by AI, either AI scientists or AI-assisted science, and actually making new breakthroughs with the help of machine learning, like the sort of machine learning we do.
So I hope you found that interesting. Please give the channel a like and subscribe if you want to find more about what's going on in artificial intelligence.